Aye, after the last episode, you've got a bit of a taste for the conspiracy now, don't you? Well, today in Dave's Garage, we're going to look at some code that Bill Gates wrote specifically to be both devious and clever. Bill's special recipe was to place character generator values encoded backwards into a trigonometry table with random garbage bits sprinkled in for good measure, so that neither the computer users nor the manufacturers would be able to spot his very secret payload. But what was it, and why did he do it? And why am I talking in a weird Irish pirate voice? All that and more, today in Dave's Garage. Arr. Arr. Hey, I'm Dave. Welcome to my shop. I'm Dave Plummer, a retired operating systems engineer from Microsoft, going back to the MS-DOS and Windows 95 days. And today, we're taking a deep dive into the history of Bill Gates' role in Commodore BASIC to follow the story of what might be the very first Easter egg ever on the desktop. Our journey takes us all the way back to the original 8080 BASIC as written by Gates and Allen to reveal the story of why Bill felt compelled to add a very clever and well-hidden Easter egg. I've got an original PET 2001 here, and we'll check out the Easter egg live on the original hardware. We'll trace the lineage of Microsoft's BASIC version 2 as seen on the Commodore, Atari, and Apple II computers, along with the story of Bill Gates' Easter egg. My programming life really began with the PET and the C64, and I was already nostalgic about Commodore BASIC V2 by the time I was working at Microsoft in the mid-1990s. I actually spent a fair bit of time going back and forth with the company archivists trying to determine if we still even had the source code to that BASIC, but we were never able to locate it. It felt as though I was the only person interested in such antiquities, and whether they had lost it or just weren't looking in the right places, I don't rightly know. Once I retired, however, the source code eventually showed up on the internet, so I was finally able to see it up close and personal in its original form. What surprised me the most, I think, was that the same code could be built for OSI, Commodore, Atari, and other 6502 platforms. For as different as they each could be from one another in some ways, they all stemmed from the same source code, more or less. It all began when Bill Gates and Paul Allen wrote the original Microsoft BASIC using an 8080 simulator back in 1975. Writing the code on a simulator is, or at least was, common practice when the target chip isn't yet available to developers, or when no real system is available to run it on yet. Years before Microsoft, Bill Gates and Paul Allen had worked together on a venture called Trafodata that used an 8008 chip to count vehicle traffic on urban roadways. Because he did not yet have access to a real 8008, Allen wrote a CPU simulator for it to run on his school's IBM 360. Presumably, this is the same simulator that he would later update for the 8080 chip when the opportunity came to develop their BASIC for it. And as we shall see, that simulator would apparently live on through the 6800 and 6502 as well. Using Paul's simulator, he and Bill toiled away at the 8080 BASIC for their first client, MITS Computers in Albuquerque, New Mexico. The target was of course the now famous Altair 8800, but they would have no opportunity to even test their code on the real machine until it came time to demo the product to MITS. When that momentous day finally arrived, Paul flew out to demo the code in person, now painstakingly punched onto paper tape that he carried with him. It would be the first ever time the code would be tried on a real machine. When they loaded their paper tape into the real hardware in order to demo it for the MITS owner for the first time ever, it booted and ran flawlessly to the OK prompt, signaling that the system was ready for user input. Paul Allen nervously typed his first command into the teletype. Print 2 plus 2. The answer came back immediately as 4. But this wasn't some lowly integer BASIC, however, like the TRS-80 Model 1 or Wozniak's integer BASIC. For example, when Radio Shack president Charles Tandy tried to enter his salary into a demo of an accounting program on his TRS-80, he couldn't do it, because the maximum value a number could contain was 32,767, and Mr. Tandy was pulling in substantially more than that, even back in 1977 dollars. Had the TRS-80 been using Bill and Paul's Microsoft BASIC right from the start, however, he would have had no such problem. That's because Microsoft's BASIC was a true floating point BASIC, meaning all numeric values had a full 6 and later 9 digits of decimal precision. Thus, when the computer dutifully and correctly printed that the number was 4 as a result, it had actually done a lot more work behind the scenes than was readily apparent. The complex nature of the floating point math routines makes it all the more impressive that they succeeded the very first time. Those specialized routines, however, were not written by Bill Gates or Paul Allen. They were actually written by a Harvard friend named Monty Davidoff. Apparently, at dinner in the school commons one day, a young Gates was complaining about not looking forward to having to write the complex math routines on the very limited 8080 CPU. But Monty chimed in that he'd done something like it before, so he could do it again. It was a move that I've made a few times myself. Claim to be able to do something that you desperately want the chance to do, and then figure out how to actually do the thing later. Which is to say, he hadn't actually done it before, but he was confident that he could, and in the end, he would. They agreed on a sum, and Monty set off to work, soon delivering the math routines that would run behind the scenes during that very first live Altair demo, and for time immemorial on pretty much every 8-bit desktop machine that would ever be released in North America and Europe. At the moment of BASIC's birth, there were no such machines yet, but in 1976 a number of 6502-based machines would appear on the market, and Microsoft would be ready, providing the BASIC for machines such as the Ohio Scientific Model 500 and the MOSTEC KIM 1. While the original 8080 BASIC had fit in 8K of ROM, various sources disagreed as to whether Microsoft was able to fit their 6502 BASIC into 8K. The reality is actually fairly simple. Microsoft BASIC fits in 8K alright, but not with enough room left over for hardware-specific code to drive displays and disk drives and printers and so on. So it actually really required 12K of ROM for a complete system. And yet, if you look at the OSI 500 and the CompuKit UK 101, the 6502 BASIC from Microsoft is only 8K. But in each case, the OEM had to include custom I/O routines in a separate ROM. From then on forward, as in the Commodore PET for example, most systems simply went to 12K of ROM and then combined the I/O code into the basic ROM. In addition to looking at the actual code, I've also spent a fair bit of time hanging out in the private Microsoft Old Timers group online, where many people have been kind enough to share their insights and information about those early days. Together, they serve to trace the lineage of Commodore BASIC from its origins in 1976, on through the release of the Commodore 64 in August 1982, the C128 after that, and beyond. And here's what the code itself has to say. Paul Allen wrote the non-runtime stuff. Bill Gates wrote the runtime stuff. Monty Davidoff wrote the math package. By the time GW BASIC made it onto the IBM PC, it was credited this way in the source code. Bill Gates wrote a lot of stuff. Paul Allen wrote a lot of other stuff and fast code. Monty Davidoff wrote the math package. Originally written on the PDP-10 from February 9th to April 9th, 1975. And by the way, if you're curious as to what the GW stands for in GW BASIC, the name was coined by Bill Gates himself, but whether it stands for Greg Whitten, an early employee in the Microsoft BASIC group, or the phrase gee whiz has never been authoritatively answered. Only apparently Bill knows for sure. We also have no mention of any credits specific to the 6502 version, however. From what I can best determine, two of Microsoft's first employees, Mark McDonald and Rick Weiland, were primarily responsible for the 6502 BASIC. Because they were developing BASIC before the machines themselves were available, they used the simulator just as Gates and Allen had before them. Mark McDonald, Microsoft's first salaried employee other than Gates and Allen, was responsible for writing a 6800 simulator. Whether he started from scratch or began with Paul Allen's 8080 simulator, or whether Allen had already added 6800 support on his own is hard to know at this point, but once the 6800 simulator was up and running, BASIC was then ported to it. By now, the simulator was really a set of macros for the PDP-10 that would allow 6502 opcodes and mnemonics to be encoded in a simple, though non-standard, syntax. The Macro 10 assembly language did not support hex numbers, which is why everything appears in either decimal or octal. It did contain a large number of convenience macros, such as load word, push word, pop word, jump if equal, and so on. Because the 6502 code was written as PDP-10 macros, the resultant PDP-10 could be executed natively on the DEC and hence would run at reasonable speed. It could also be translated directly into a 6502 binary, thereby giving you a complete code, compile, test, and debug cycle. The basic code is also highly configurable at build time, allowing you to turn off or on various features and attributes based on the flags that you provide. For example, add precision, the flag, would extend math precision from 32 bits to 40 bits, which is to say from 6 decimal digits to 9. If extio is defined, then you get the print number, input number, open and close commands that you see in Commodore BASIC. If disco is defined, then load and save are enabled, and so on. I've not heard that Microsoft ever offered BASIC features to OEMs in an a la carte pricing fashion, so I presume this is primarily a build convenience that allows the source code to remain the same across numerous different OEMs. And with McDonald's new 6502 support in the simulator, Rick Weiland undertook to port the 6502 BASIC over to it. Unfortunately, Rick Weiland passed away in 2008 and Paul Allen 10 years later in 2018. The number of survivors that actively contributed to the early Microsoft BASIC in earnest dwindles further and further as the decades pass, which is why I think it's doubly important to ask and answer some of these historical questions now. While it would be wonderful to talk to Mark McDonald or Bill Gates about these origins and these early days, suffice to say both fellows are rather hard to get as guests. And so, back on the trail of Commodore's BASIC, the very first commercial release of 6502 BASIC was version 1.0 in the ROM of the Ohio Scientific Model 500. The included BASIC is different from its successors in two major ways. It uses 6-digit precision for floating point, and it contains a major bug in the garbage collector. While retaining the 1.0 version number, BASIC next picked up 9-digit floating point as a fix for the garbage collector before being shipped on the MOS Kim 1. In both the OSI and MOS Tech cases, the two-line startup banner made plain where the BASIC originated, with Microsoft. The top line contained the computer manufacturer, the CPU type, the language name, and the full version. The second line was reserved for Microsoft's copyright. And this is where I think the problems truly started. Because while the Commodore Kim 1 would follow this trend of allowing Microsoft to get credit for the BASIC interpreter, the PET would not. Before shipping, Commodore would strip the Microsoft copyright out and reserve the startup banner entirely for its own vainglorious boasting. In fact, it didn't even say Microsoft anywhere, so how could Microsoft even prove that they were the authors of this BASIC? That seems to be the origin of most great Easter eggs, a desire to prove true authorship. And so that's the essence of an Easter egg, but what was the first one? And the thing is, if you include mainframes and mini-computers, they actually go all the way back to at least the DEC PDP-6. If you ran the make command and provided the word love as a single argument, then your make love command would be greeted with the response, not war, before proceeding. So that goes back to 1967 at least. When it comes to games, we find one in a very early version of Lunar Lander. Back in 1973, DEC commissioned the creation of a real-time graphical version of the game intended to showcase their new graphics GT140 terminal. The game was written by Jack Burness, and it came as a demo with your brand new PDP-11 and was featured at trade shows and so on. It looks substantively like every other Lunar Lander game that would follow in its footsteps, but with one curious addition. If you flew far enough laterally, rather than wrapping around, the game ended at a McDonald's. You could land your ship and your astronaut would walk on in and visit the Golden Arches. And of course, at this point, in their head, anyone under 30 is likely picturing a first-person simulation of walking up to a McDonald's in a Wolfenstein on the moon for burgers. But no, I just mean a little vector drawing of the dude, and the little stick man would pop out of the ship and go towards it. But there it was as a hidden touch just for fun, so it qualifies as the first video game Easter egg. In the home and office, the one that made Easter eggs famous and that popularized the use of the term was the Atari VCS game Adventure. It's certainly the first Easter egg in a video game for the home and the first mass market example. Atari did not include any credits for the programmers, in part to prevent them from being poached by other game companies. The programmer of Adventure, however, disagreed with that policy and added a secret room that could be accessed by standing on a particular single pixel within the game. Once inside, the secret room contained the message created by Warren Robinette. It's the perfect example of an Easter egg, and for all the right reasons. Suddenly, Atari was faced with a hard problem. They initially wanted to recall all of the game cartridges and remove the message, but once they worked out what it would cost, they decided to embrace it instead. They even went so far as to promote news of the Easter egg and use the term Easter egg itself. Atari ultimately reversed this policy and later started to encourage the inclusion of Easter eggs in its games. In the mid-1980s, Commodore was not quite so lucky. Their initial Amiga operating system contained an unfortunate message. We made the Amiga. Commodore f***ed it up. Except they weren't on YouTube, so they said the whole F word and everything. I remember reading that they started recalling machines at first, but when the cost started to really add up, they released a software patch on the boot disk that just disabled it instead. They simply replaced it with a less offensive message. And that's where Bill's Easter egg comes in. Because all we have to do is walk up to any pet in the world running BASIC 2 and type a single command. Wait 6502, 100. The wait command, if and only if it contained that exact 6502 parameter, would trigger the Easter egg. Let's have a look at it live now. Once you enter the command, up comes a Microsoft banner as many times as you specify for the second parameter. The text is 10 characters, so it fits on a line 4 times, and the screen is 25 lines, so wait 6502, 100 is about optimal to entirely fill the screen. Some of you might be familiar with the stolen from Apple Easter egg in the Macintosh. It's something that Steve Jobs had added to the Mac ROM in order to be able to prove whether a clone machine had copied Apple's ROM or truly written their own from scratch. I believe that the Wait 6502 Easter egg is something similar. It was a way for Bill to be able to walk up to any computer with a Microsoft CBM BASIC ROM, enter a single command, and fill the screen with Microsoft. This was important because a computer like the PET was built largely from off-the-shelf parts. it would not be difficult for a company to duplicate the hardware closely enough that Microsoft's BASIC would run perfectly on it. Then it's a simple matter of changing the startup banner to read Clone Co. or whatever the company name is going to be. Copy the ROMs for free and only Microsoft loses out. Imagine the impact that such a secret Easter egg might have in a court of law. Just after the opposing chief engineer had finished testifying that the ROM was a clean sheet design, completely made in-house without any Microsoft code, Bill could walk up to the computer and type this obscure command, wait 6502, and everyone in the courtroom would witness as the screen filled with the word Microsoft. Case closed. When Compaq wanted to clone the IBM PC, they were in a similar situation. The hardware to build a clone PC was widely available, and the only barrier to making such a clone was the software. The IBM BIOS code was proprietary and copyrighted. Compaq couldn't just duplicate the ROM chip and sell it as its own. To make a clone, they would have to write the entire BIOS from scratch on their own, and they'd have to do it in a way so as to be fully and exactly compatible with every behavior and quirk that the IBM PC had. They could look at the documentation and see what parameters were passed to the code and what registers, and they could have the code perform the exact same task and return the exact same result, but it had to be done entirely from scratch in their own code with no reference and never looking at anything from IBM. The only way they could do it legally was to start with only the docs. They had to find engineers who had never touched a PC effectively, because any time spent looking at the ROM, or worse, reverse engineering it, meant that the engineer was contaminated and couldn't work on the project. Only developers with no real exposure to the thing could contribute, and everything they wrote had to be based strictly on the docs, since that, of course, was all that was public. The term BIOS stands for Basic Input and Output System, and that's precisely what it contains. Code to do things like display a character on the screen or to read a character from the keyboard. To call the BIOS on the PC, we generate a special interrupt known as int10. When that interrupt happens, the dispatch handler looks at the AH register to determine what to do, and the rest of the registers may or may not contain parameters depending on the call itself. In our example, when int10 is fired with the 14 in the AH register, the contents of AL are then written to the screen. How it does it might be completely different between a Compaq and the IBM, but the important thing is that the Compaq BIOS had the same runtime effects, and in some cases, the same important side effects, as the IBM version, without infringing in any way on the IBM copyright. On the other side of the coin, we have the Accelerator Plus disk drive that was released for the Commodore 64. To be compatible with the Commodore disk ROM, the makers of the Accelerator simply copied the Commodore ROM, and naturally, they were then sued by Commodore, who rightly won the case. Their genius solution was to swap a few data lines on the ROM around, scramble the ROM contents accordingly, and then just try to hide the crime. Of course, Commodore figured that out in fairly short order and sought injunctive relief to stop them from selling it. The legend holds that Bill's Easter egg was to prevent something similar, but not quite the same. That Bill was concerned that Commodore, who had signed only a flat fee license with Microsoft, would somehow abuse the terms and then use that code in or on a machine where they didn't have the rights to do so. Using the secret Easter egg as forensic evidence, Bill could conclusively prove whether a competitor's ROM was a copy of Microsoft's or not by the presence of the Easter egg. The common legend is that Commodore is said to have only paid that one time and never returned to Microsoft for any updates, which drove Bill nuts, and it created intense animosity between him and Commodore chief Jack Tramiel. But that's demonstrably false, because the Easter egg is not present in the CIM-1 BASIC, but it is present on the PET 2001 BASIC a year later. It's a safe assumption that it was Microsoft who added the Easter egg, and that Commodore must have come back for at least a second revision. Not to mention that there are also different version numbers entirely, and the company name changes from MOS to Commodore. Hence, I don't think I'm very far out on a limb in asserting that Commodore came back to Microsoft at least one time between the CIM-1 and the PET 2001. But it could have even been before Commodore purchased MOS, so maybe it doesn't count. I don't know. Who was there? Were you in the room? Let me know! After receiving BASIC version 2, however, Commodore would decide good enough and would continue to develop and refine the BASIC entirely on its own pretty much forever after, never having to pay Microsoft another penny. Unlike every other version of Microsoft BASIC in the day, Commodore's startup banner is the only one that does not credit Microsoft, so it's entirely possible that the Easter egg is simply to give credit to Microsoft. But I doubt it. When Commodore found out about the Easter egg, they were less than impressed. The late great Commodore expert Jim Butterfield wrote at the time, "Shortly after that implementation, I showed this to Len Tramiel of Commodore Engineering at the Commodore booth of the CES show. He was enraged. We have a machine that's short of memory space and Gates put that kind of stuff in it." Commodore employee Andy Finkel wrote that they removed the Easter egg not to slight Microsoft, but to save the 51 bytes that it had been consuming. Commodore had discovered and removed the wait Easter egg, which took place sometime between the PET and the Commodore 64, and they didn't come back to Microsoft for a refresh ever again, as I said. it would seem all traces of Microsoft were removed from the public face of Commodore BASIC, right up until we see Microsoft's name return in BASIC version 7 on the Commodore 128. All signs point to that as being a result of Microsoft being able to exert its leverage acquired during the negotiations for doing Amiga BASIC. Michael Stiel over at pagetable.com has a really nice breakdown of the technical details of the Easter egg, and I'll point you at his page in the video description if you want all the gory assembly language details. But to me, the really interesting part is how Bill hid the ASCII text for the word Microsoft. He did 4 important and reasonably clever things to keep it hidden from Commodore's notice. First, and most simply, he put the text in memory backwards, which, believe it or not, makes it a lot harder to scan for with a typical machine language monitor, at least of the day. Secondly, he randomly set bits in the upper 2 slots of each character. Since the uppermost bit isn't needed for alphabetical characters, and because the other bit is just used for case, they can both be ignored and stripped out if you're just doing uppercase text, as he was here. Third, he stored the garbled backwards text in a very inconspicuous area of memory. The data itself is stored right after a table of coefficients used by the sign function, such that it appears to just be more random-looking data at the end of that table. And fourth, it's stored using character generator codes and not ASCII or PETSCII as one might expect. If we take the bytes from the end of the trig table and reverse them, we get the following bytes. If we then clear out the uppermost 2 bits, we get this set of bytes, which is still not ASCII, but it's not PETSCII either. Rather, it's an encoding using the raw screen codes used by the character generator chip. While the uppercase A normally appears as ASCII 65, it's also found at screen code location 01. In other words, on a PET, when you poke the index of a letter of the alphabet into memory, you get that character on screen. An A is a 1, an E is a 5, and so on. And that was Bill's special recipe. Character generator values encoded backwards into a random trig table with garbage bits sprinkled in for good measure. It's also important to note that there's nothing about this Easter egg that makes it specific to the PET, other than the text encoding, and that's fixed by setting a single bit. In fact, there's nothing even 6502 specific about it. Believe it or not, that obfuscated Microsoft text that is stored in the trig table is included in all the source code to all the versions, not just the Commodore version. They're even there in the AppleSoft BASIC. Bill's Easter egg exists only in version 2 of BASIC on the PET. Later, Commodore computers like those running BASIC 4 did not have it. If we go back a little further though, we discover something interesting. The Easter egg text, Microsoft exclamation mark, is actually present on the KIM-1 as well, at least in the 9-digit precision version. In this case, however, the text is plain ASCII, which has been exclusive word with 87 hex. The KIM-1 appears to be the first appearance of the encoded text in the trig tables. Every non-Commodore 6502 machine released after 1978 includes the encoded text, still in the PET screen codes. But wait, there's more. Even the TRS-80 color computer contained the hidden text in the trig constants. In the color computer ROM guide, they're just listed as unused garbage bytes. If you enjoy this style of nostalgic technical tale, please encourage more of it by subscribing to Dave's Garage. You don't have to turn on the bell icon, I'm not greedy, but I am primarily in this for the subs and likes, so please be sure to leave me one of each before you go today. Thanks for joining me out here in the shop today. In the meantime and in between time, I hope to see you next time, right here in Dave's Garage. This little chair will be waiting for one of you, and a rocking chair for another who likes to rock, and a big armchair for 2 to curl up in. All next time on Dave's Garage.